Everyone, we are now at our last topic, which is differential equations. So let's jump into it. dy dx equals f of x is an example of a first order differential equation. The term first order because dy dx is the first derivative. If it was saying d squared y upon dx squared equals f of x, it will be called a second order differential equation. But that's fine. You don't have to be concerned with that at this stage. Now it says, to solve a differential equation, we integrate both sides. But first, before we go ahead and start solving, we have to make sure our equation is set up correctly, meaning we need to separate our variables. All the x's need to be on one side and all the y's on the other side. Now, here we have dy dx equals 2x plus 3. So we're going to leave this dy on that side and bring this dx to the opposite side. Since it was being divided, when it crosses the equal sign, it gets multiplied, as you can see here. So now that we have separated our variables, we can integrate both sides. If we integrate dy, we will get y. And if we integrate 2x plus 3, the integral of 2x is x squared, and the integral of 3 is 3x. And we put our plus c at the end. So here is our solution. Y equal x squared plus 3x plus c, and because of this plus c, it is referred to as a general solution. In our second example, it says, solve the differential equation x squared dy dx equals 4 minus x raised to the 4 when x equals 1 and y equals 2. So first thing we have to do is separate our variables. Here we have x squared on this side. We're going to bring it to the opposite side. Since it was being multiplied on this left side, when we bring it to the right side, it's going to get divided. What I did was gave each component the denominator of x squared. So I wrote 4 over x squared minus x to the 4 over x squared, because it will make it easier to simplify than integrate. This dx will also need to be brought to the right hand side. Now, when this is simplified, 4 over x squared is the same as 4x raised to the negative 2, and x to the 4 over x squared, when we divide, we subtract the powers, giving us x squared. Here is where I brought over the dx to the right hand side. So now our variables have been separated. We have the y on one side and the x's on the opposite side. So now we can integrate both sides. If we integrate dy, we get y. If we integrate 4x raised to negative 2, add 1 to the negative 2 to get negative 1, and divide by negative 1, making this now a negative 4. If we add 1 to 2, we get 3, and we divide by 3 plus c at the end. Now we were given some particulars in our question. It says that x is equal to 1 and y is equal to 2. So we will substitute these values in their corresponding locations. Since y is 2, we'll plug a 2 in this location, and we'll also plug 1 wherever we have an x. Now, negative 4 x raised to negative 1 can be rewritten as negative 4 over x, as this x gets brought down to its positive. And now we can plug our 1. So it becomes negative 4 over 1 minus 1 cubed over 1 plus c. We're solving for c. So we're going to take both these values to the opposite side. So the equation reads equals C. This will be a negative 4 brought over to become a positive 4. This will give us a negative 1/3 brought over as a positive 1/3. So now we have 2 plus 4 is 6, plus 1/3, 6 1/3. So therefore our C is 6 1/3. So now we can plug everything and our solution becomes y equal negative 4 over x minus x cubed over 3 plus 6 1/3, which we found as our C. And this right here is referred to as the particular solution. So we have some questions that follow. So there are 2 steps. First, you separate the variables, then you integrate both sides. So here it says, find the general solution to dy dx equals 4x cubed minus 2x plus 1. This dx will be brought up. Now we can integrate both sides. Integrate dy to get y. Here when we integrate 4x cubed, we add 1 to the power to get 4 and divide by that 4. This x already has a power of 1. When we add 1 to that power, we get 2, then divide by that 2. And if we integrate 1, we simply get x, and we put our plus c at the end. So now our general solution reads y equals x to the 4 minus x squared plus x plus c. In our second question, we have dy dx equals sine half x. Once more, we'll separate our variable, so this dx gets brought up. Now that we have separated, we can integrate both sides. If we integrate dy, we get y. And if we integrate sine half x, we get negative 1 over half cos half x plus c. Simplified, negative 1 divided by a half will be a negative 2, making our general solution y equals negative 2 cos half x plus c. In our third question, we have dy dx equals y squared over square root of 3x plus 1. So we're going to first separate our variables. This y squared, that's a numerator, will be brought to the opposite side as 1 over y squared, or y raised to negative 2. This dx gets brought to the opposite side. So now, this y squared is now y raised to negative 2 when brought over, and we're integrating this side with respect to y. This that we're left with is a 1 over root 3x plus 1, or 3x plus 1 raised to a negative half. Now we can integrate. If I add 1 to the power, we get negative 1, then we divide by negative 1. On this side, it's a linear factor, so when I add 1 to negative half, I get half, and I divide by half. But if you recall, when we do that, we have to multiply it by a, which is the coefficient of x. So now we have 3 times a half is 3 over 2, which gets brought up as its reciprocal, 2 over 3. Now, y raised to negative 1 is the same as 1 over y. And since it's being divided by negative 1, it can be rewritten or written as negative 1 over y. So this here is our general solution. Negative 1 over y equals 2 over 3, 3x plus 1 raised to the half plus c. In this fourth question, we have x squared dy dx equals y squared. So first we separate our variables. This y squared will get grouped with the dy, and this x squared gets grouped with the dx on this side. Now, this y squared will be brought over as 1 over y squared, or y raised to the negative 2, whilst this x squared will be brought over as 1 over x squared, or x raised to the negative 2, as you see here. This dx gets brought over as well and gets multiplied, because on this side it was being divided, so it goes up and gets multiplied. So now that the variables are separated, we will integrate. If I add 1 to negative 2, I get negative 1, and I divide by negative 1. Just as we did in the previous question, we'll get a negative 1 over y. So in the same way, if I integrate x raised to negative 2, I will get a negative 1 over x. Put my plus c at the end. Last question. dy dx equals y squared plus 2x y squared. So we have to separate our variables. First, I factor out the highest common factor y squared to be left with 1 plus 2x. Now I can separate. This y squared is brought over as 1 over y squared, gets grouped with the dy, and this dx is brought up next to our 1 plus 2x. So now that the variables were separated, we will integrate each side. Once more, if we integrate y raised to negative 2, we'll get 1 over y. On this side, if we integrate 1, we'll get x, and if we integrate 2x, we get x squared. Plus c goes at the end. Now, we have an application of differential equation. Now, this aspect has been on all 3 past papers, so you need to pay close attention. We're going to start with an example. It says, during a snowstorm, the ice on a windscreen is X millimeter thick at time T hours after freezing started. After 2 hours, the ice on the windscreen is 3 millimeter thick. The rate of increase of X, remember X is the thickness of the ice, is proportional to 1 over x. So first they want us to set up a differential equation for x. Now let's work with the information that's given. It says the rate of increase of x is proportional to 1 over x. So let's write that down. Rate of increase of x will be expressed as dx dt, meaning as x changes, meaning as time passes, x changes. Rate of increase of x is proportional to 1 over x. So this is our proportional sign to 1 over x. Now, the rule of mathematics is to change a proportional sign to an equal sign, you have to multiply by a constant. So that's how we now have dx dt equals k times 1 over x. So previously we learned that to solve a differential equation, we separate our variables, then integrate both sides. So that's what we'll do now. This x that's below will be brought to the opposite side and gets multiplied by the dx. This dt that's below will be brought up to the opposite side and get multiplied by the k. So now we have x dx equals k dt. So now we can integrate each side because the variables have been separated. If I integrate x, I will get x squared over 2. And if I integrate k with respect to t, I will get kt plus c. So this here, we've set up our differential equation. Part B says, using the model, find the time at which the thickness of the ice is 5 millimeter. Now, if we go back to the question, it says, the ice on the windscreen is X millimeter thick at time 2 hours after freezing started. Now, so when no time has passed, meaning when T is 0, there is no ice on the screen. So we will start with that. When T is 0, X is 0, and we will plug these values into the differential equation that we had. So this is our differential equation. We're going to plug T equals 0 and X equals 0, and that will help us to solve for C. So here, 0 squared over 2 is 0. T is 0, so 0 times K is also 0. So therefore, our C is 0 as well. Let me repeat. When the time is 0, the thickness of the ice is 0. So plug in X equals 0 and T equals 0 into the differential equation. 0 squared over 2 is 0. 0 times K is 0. So our C that we're solving for is also 0. Now, the next part of the question says that after 2 hours, that's when T is equal to 2, the ice is 3 millimeter thick. So when T equals 2, X equals 3. We're going to now plug that into the differential equation. So, remember, C is 0. So, 3 squared over 2 will be 9 over 2 is equal to 2K, because that's a 0. Remember that time is 2 and thickness X is 3. So that's all we have. 3 squared over 2, or 9 over 2, equals 2K, as you see here. So we can now solve for K. This 2 will be brought to the other side and get divided. So therefore, K is 9 over 4. So we've solved for C, we've solved for K. Now we can go to the question and find the time when the ice is 5 millimeter. So we want to find T when X is equal to 5. So once more, we're going to the differential equation. Let me put it here. X squared over 2 is equal to KT. So we're finding T when X is 5. Now, this gives us 5 squared over 2 equals K, which we found to be 9 over 4 times T. So when we solve for T, this 9 over 4 that's multiplied is brought to the other side and get divided or reciprocated. So when we multiply 5 squared, 25 over 2, with or 4 over 9, we get 2 times 25, 50 over 9. So this is the time at which the thickness of the ice is 5 millimeter. 50 over 9, or 5 and 5, 9 hours after freezing. In our second example, it says, a puppy has mass 40 grams at birth. The rate of growth of the puppy is modeled by the differential equation dx dt equals 90 times t minus 4 all squared, where x is the mass of the puppy at t months after birth. Find the mass of the puppy 3 months after birth. So first we have our differential equation, which we will get a solution for. So first we will separate our variables. This dt gets brought up and grouped with this part of the equation. So we now have dx equals 90 times t minus 4 all squared dt. Now that we've separated the variables, we are going to integrate both sides. If I integrate dx, I will get x. Here, when I integrate t minus 4 all squared, I'll be using the linear factor method. So, add 1 to the power to get 3 and divide by 3. And that gets multiplied by the coefficient of t in this case, which is 1, so that makes it easier. So, when simplified, 90 divided by 3 is 30, and making our differential, the solution, x equals 30 times t minus 4 all cubed plus c. Now, the question says that at birth, meaning when the time is 0, baby puppy has just been born, its mass is 40 grams. So let's work with that. Remember, mass is x and t is going to be 0, meaning at birth. So when t equals 0 and x equals 40, we're going to plug that into our solution, general solution. This gives us 40 equals 30 times 0 minus 4 is a negative 4. We'll cube that and our plus c goes back. So when we solve for c, this will give us a negative 64, gets multiplied by 30, giving us a negative 1920, which gets brought over as a positive and gets added to the 40, making c equals 1960. So now that we have solved for c, we can find the mass of the puppy at 3 months. So we're finding x when t is equal to 3. So we plug t into the solution and solve for x, giving us 30 times 3 minus 4 all cubed plus 1960, as you see here. So when we solve for x, 3 minus 4 is a negative 1. We cube that. We still get a negative 1. Gets multiplied by 30 to give us negative 30. So negative 30 plus 1960 gives us x equals 1,930 grams.